Hello and welcome to today's roundtable. My name is Sten Bühner. I'm the Managing Director of IREB, and I'm happy to welcome you today to our roundtable session on requirements engineering and systems engineering. I'm happy having two panelists today for the discussion, Tim Wilkins and Christian Bock. And just to inform you beforehand, the session today is recorded, means you could also watch the session by yourself or share this within your network on YouTube or also on LinkedIn after the session directly. And if you have any questions during the session, doesn't matter and when, please just use the chat to ask your questions, and I will try to moderate them into the session that the panelists could answer them, and we can have an interactive session today. So, as already mentioned, today we are focusing on requirements engineering and systems engineering. So maybe let me briefly set the theme. When we look to today's products, they are getting more and more complex. They are not isolated solutions anymore. They are interconnected systems. And sometimes, especially in organizations, introducing a kind of formal systems engineering often feels quite too big and too heavy and maybe too disruptive for the organization. So the idea for today, what we want to discuss, is how organizations could move towards systems engineering and towards system thinking in a more pragmatic way. And we would like to ask the questions to ourselves within the panel, if maybe requirements engineering could be a natural starting point for this action, just to have organizations that are more mature in, let's say, developing systems and in systems engineering itself. So I'm happy today having two experts in this area, Tim Wilkins and Christian Bock. Maybe, Tim, will you start with a short introduction of yourself?
Oh, yes, sure. Thanks for the invitation, Stan. Yeah, I'm Tim Wilkins. I'm consultant and trainer and board member at OSE. And I've been promoting MBSE or systems engineering in general for over now 20 years, directly with our customers in training and consulting projects, but also in standardization. I have been active in the OMG, the Object Management Group, also for over 20 years, most recently as the co-chair of System LV1, and now as the co-chair of the System LV2 revision task force.
Perfect. Thank you, Tim. Christian.
Thanks, Stan, and thanks for having me, of course. Very warm welcome from my end as well. I'm Christian, and I unfortunately don't have such an extensive background as Tim has, for that matter. However, I'm also working in requirements and systems engineering for a decade now, starting with like 8 years of consulting experience in different fields, ranging from insurance over automotive towards medical devices. And I'm now currently working as head of requirements engineering at Ziel ABEC. And I can only highlight what Stan already said, because that's exactly what applies to us as well, coming from typical mechanical engineering company in the Swabian outback, so to say. We evolved towards developing complex products, fans, elevator drives that are now more and more also using software to provide functions to our customers. And therefore, I can currently collect first-hand experience on our topic for today, and I'm more than happy to discuss these topics with Tim, Stan, and of course with the audience as well.
Perfect, great. Thank you, Christian. Good. Having a look into more details. So I think before starting into the discussion, maybe let's set a brief theme that everyone has a shared understanding of what we actually mean with systems engineering. I think sometimes, depending on your domains, the terms may be different and used in different ways. And before we go into the discussion whether requirements engineering could be used to implement systems engineering in certain organizations, I think we first need to understand what systems engineering is in our perspective. So setting the theme to Tim, and you may start with a short introduction, what you think from your perspective systems engineering is.
Yeah, I will try it. Of course, I know what systems engineering is, but it's not so easy to explain it in a minute, so in an elevator pitch. Well, first, it's a discipline. So it includes processes, tools, roles, everything you have in a discipline. And it's also a kind of a mindset. It's based on systems thinking, which is, well, the ability to understand how parts of something interact together and influence each other over the time. And in systems engineering, we are in particular interested, of course, in systems that are created by those parts. So this slide that you see here, that shows the cover image of the INCOSE Vision 2025. So INCOSE, the International Council on Systems Engineering, is the association for the discipline. And they have published this Vision 2025 10 years before, so 2015 now. And there's also a Vision 2035, of course, because 2025 is already history. But anyhow, I like this image of the Earth, and the title perfectly hits the nail. Now, it's about complexity, but that's our main challenge today, complexity and motion. So at the same time, dynamic. So complexity and speed, that's the challenge. And systems engineering helps mastering the complexity because it's about mastering the whole thing. Of course, this INCOSE has a definition for systems engineering. It's a little bit longer than here. This is a short version, but it shows two main aspects here. The first one, the systems engineering is a transdisciplinary approach. So it's about connection of involved disciplines. And the other aspect is that it's not only about the development of systems, but it's about the whole life cycle of a system. So the realization, use, and retirement of the systems. And of course, I should also mention MBSE here, but that's simple. MBSE is SE. It's systems engineering. That's not different. It's doing systems engineering with models. So there used to be a lot of buzz about it in the past, but it's like train-based traveling or internet-based roundtabling here. It's not so important to emphasize on the tooling. It's just doing systems engineering with models. Don't worry, I don't dive here into the processes, but very quick, the foundation of systems engineering is this ISO standard 5288, which lists the systems engineering processes. And the interesting part is here more on the right side. On the left side, you see all the technical processes, but on the right side is also non-technical stuff like HR management, supply chains, and so forth. That's also part of systems engineering. So it's really a huge discipline. And requirements engineering is also here. It's an important pillar, but it's only one of many pillars here in systems engineering. These three processes covers requirements engineering. If you're interested in more, don't read the standard. That's reading a standard is not much fun. There's the INCOSE handbook that explains the standard and much more. It's for free for INCOSE members and costs not very much money for non-INCOSE members. And with that, I hand over back to Stan.
Great, thank you. So question is, when looking to the definition, kind of transdisciplinary, life cycle oriented things, what do you think, where can we actually need more kind of requirements engineering, or where could requirements engineering help in the situations?
Maybe I can start with my first take on that.
Yeah.
From my personal experience, which I will also share later on throughout the roundtable. By the way, Tim, I liked the verb roundtabling a lot in your brief discussion, in your brief introduction. From my personal experience and what I'm experiencing right now with requirements engineering, we have an amazing opportunity to actively involve the other processes that Tim just showed, with requirements engineering only being like a little part of the overall development lifecycle or general product lifecycle. And through requirements engineering, we have an amazing opportunity to get that holistic thinking that you talked about, Tim, going by involving the other disciplines or the other process owners or whatever you want to call them as stakeholders in the requirements engineering process.
Yeah, I think requirements engineering is, well, independent of systems engineering, so it's extremely important. It's focusing on the problem. We tend to focus on the solution, but requirements engineering is about the problem. So it's the same in software engineering. Software engineering is also important to have a focus also on the software requirements. But if we cover the whole product, then we are on the system level. And if we do the system requirements, well, we do systems engineering. If you call it systems engineering or not, it's systems engineering. So all organizations that build products do systems engineering.
whether they like to call it that or not.
Yes.
Definitely, yeah, totally with you on that.
Mhm.
Yeah, I think it's a fair point. I think especially today, maybe many organizations who are, let's say, really building products in the combination of hardware and software mostly. Not sure. Sometimes they only call themselves a kind of product engineering or product development or whatever. I think systems engineering is not quite often used. I'm not sure why, because I think the term system is really the term that should be used in this matter.
Yeah, but it's just a name, no? So if you can call it product engineering, and some people say product engineering is different to systems engineering, yeah, you can discuss these definitions if you like, but in the end, it's about building something interdisciplinary. No?
So when looking into organizations, I think, Christian, here you can give some insights to the organization you are working for, because they are it's not a typical software engineering organization. So what do you see, what typically happens in these organizations when they have this kind of complex products? The complexity increases with software and the combination of hardware, and what's happening there, especially if systems engineering is not available as of now, and what are the pain points in this area?
Yeah, I have prepared a few scenarios that are first-hand experience from problems that can potentially occur in such scenarios. I think the most important point, as you have already mentioned, Stan, is that it has to be kind of like also learned how systems engineering works, or to think in systems. As I've already said in my introduction, we are coming from a more simple world, or from more simple products, where it was kind of reduced to mechanical engineering only. So you had mechanical parts that were kind of not necessarily dumb, but that had not too much intelligence, or so to say, software coming in, as you have now, making the products more complex and highlighting even more what I think, Tim, you already said in your definition, the transdisciplinarity, that you didn't need too much when the products were composed of less components and had less complexity. I think there's less transdisciplinarity necessary there, because less disciplines are involved. But with the products getting more complicated and complex even, I think that makes it potentially more challenging, or even more problematic, to kind of get a grip on the product development itself. So maybe to just make some concrete examples on what I observe in our organization, is a first scenario is that we oftentimes experience a lack of alignment in component development. So to make an example, right there, we had a development project for a new product group, and the hardware colleagues were planning to do some tests that required a certain software function that the software colleagues didn't know that was required for that testing at that certain point in time. So what they did, they didn't, of course, prioritize it, because they weren't aware even that that functionality is required at all, or even at that point in time. So the consequence of that was that, as you can imagine, there was a delay in the project schedule. The software team had to spontaneously shift their priorities, and that resulted in not too much happiness or even frustration, and of course, a lot of stress for all the parties that were involved on both sides. The hardware team that couldn't fulfill their plan with the testing they wanted to do, and on the other side, of course, also for the software team that had to throw their plan overboard and had to reprioritize and replan on a short notice. And that, from my personal point of view, could have been prevented through systems thinking and a more holistic planning approach if you would have aligned between the different disciplines. Again, highlighting the interdisciplinarity or transdisciplinarity for that matter. Another example, or a second scenario that it kind of happens a lot, but just to make it a little more concrete, is that we have misunderstandings, not necessarily between different divisions or different teams in the product development itself, but between the different disciplines that are involved in the product lifecycle. Like, for example, we oftentimes experience problems or misunderstandings, misalignments between the development teams and manufacturing, because manufacturing, of course, has to focus on having the having the sites running, having a high production output, and not necessarily on being involved in development projects too much of their time, because that's eventually not what they're measured for. So therefore, manufacturing or colleagues from manufacturing are often only sporadically involved in the development projects, and therefore not necessarily, as we've already discussed in the previous question, are not necessarily serving as stakeholders as much as they probably should or would need to. And that oftentimes leads to the problem that the development departments create system designs that are not necessarily fit for manufacturing, which only comes up when at a later point in the product lifecycle, we are starting to approach the manufacturing side or even try to make first samples in the production sites. And then there are problems coming up with incompatibility with existing machinery and so on and so on. And to redact or to detect those mistakes, so to say, or those design flaws that leads to bad manufacturability at such a late point in time, of course, makes it rather costly, and also again crashes the timeframes of projects quite often. And again, those could have been detected earlier if we would have considered the whole product life cycle during development already. And also, just to make a third scenario, and then that's it from my end with the examples from our personal experience, we oftentimes experience through the products getting more complex, unclear responsibilities when it comes to system functions. So when we have interdependencies between different components that only create a valuable function once they work together, probably. Because what we have experienced is that there's a system function that is required and can potentially be solved either solely mechanically, solely through a software function, or through a system function that is realized through contributions of both. So in one project, we had the problem that the mechanical design has chosen a solution that only makes sense if a corresponding software function is there to detect something and then consequently takes action to, for example, shut down the fan before anything bad happens, just to make an example. So the mechanical design was based on the assumption that the software team is developing that function to detect and to shut off the fan in a certain case or in a certain scenario. But the software team wasn't aware that a contribution from their end is required because it was only an assumption that was not communicated by the mechanical team to the other teams. And therefore, the software team, once they were made aware that this function is required from them, did investigate the feature and came to the conclusion that it was not feasible for them to realize that function. So the consequence of that being that the system function had to be redesigned entirely at a rather late stage of the project. And that again could have been prevented through a thorough functional decomposition and thorough allocation of function contributions to components, which did not happen in that case. But as it is so often, you learn from your mistakes, and it probably will not happen, at least not that often in the future, at least I hope so. So that are just some examples from my personal experience, what can happen if you don't do enough systems engineering or if you have not necessarily learned the systems engineering principles by heart already.
Okay, great. Thanks for the impressions, Christian. Just thinking loud now when you talked about, let's say, different consequences and what has been missing. You mentioned in the very beginning the concept of systems thinking, and I'm not sure if everybody is in the session is aware what systems thinking means. So maybe you spend a few words on what system thinking is.
Yeah, sure. Historically, I'd say that you rather think in silos more than you think in the system as a whole, spanning multiple teams, multiple departments, depending on how your organization is designed. So what system thinking means is, I think as Tim also briefly mentioned in the systems engineering introduction, is to not only see components individually, but to have a view on the system or the product to be developed as a whole. And that's what I would consider systems thinking, to not only think about what does a single component need to do, but rather to start thinking from what do we need to deliver as a whole, and then to break it down further into the components and the contributions they need to make in order to fulfill the corresponding system or product function in total. But Tim, please feel free to extend or correct that.
No, that's it. I think thinking in the whole, it sounds so easy, but it's yeah, you must experience it. So and don't think in these causal chains. No, it's not a cause and an effect. So the effect is the cause for the next one, and it's not a single line. It's more a network that happens. So and to overlook this. Yeah, and I think that's a contradiction in many projects. Now, of course, we need more systems thinking, but at the same time, we cannot burden everyone that they have to think about everything. It's not by accident that organizations are organized in functions. Now we have the people that think about marketing, and we have the software engineers, the hardware engineers, and so forth. And of course, that's good. That's a benefit. But at the same time, we need the systems thinking. So the hardware engineer must also think about the software stuff and the other stuff. So there's a contradiction, and it's not so easy to resolve that. And there, systems engineering comes into play, but often it's not the good idea that, okay, we have another department, the systems engineers, then we have another silo. So introducing systems thinking is not easy, but introducing a mindset is not easy. No? It's not a tool that people learn or a process that people learn. It's a mindset. No?
Yeah, absolutely with you. And that's also what I experience in my everyday work. It is more about bringing the necessary people together, because as you've mentioned, the hardware engineer can potentially not really know which consequences his decisions may have for the software department. But then the important thing is that he at least thinks about that there are consequences for software potentially, and then goes to talk to the responsible people to clarify how they need to interact with each other. And that's, I think, what people should learn, need to learn, and what has to be established in the organization as a mindset eventually.
When you say this needs to be established in the organization as a kind of mindset, this for sure brings also a kind of, let's say, rethinking the organizational structures, having maybe dedicated roles, even if roles, Tim, as you mentioned, may just create another silo that with some people who are, let's say, thinking in systems. But I think maybe this is not the best way to just have whatever department that's thinking in systems, and the others are just thinking in their silos. So what do you think when introducing systems engineering into an organization? Do we need a kind of transformation program? Do we need more a kind of, let's say, mindset that is somehow trained for the people, that they think more holistic? Doesn't matter if they are marketeers, if they are software developers or hardware developers. What was your experience here?
Well, it's a transformation process. So if you really would like to systems engineering is always there, but if you would like to do this explicitly and put this into the organization, you need a lot of stuff. You need this mindset thing. So you need trainings or whatever in this field. You need also the trainings about the more boring stuff like the processes and so forth, and the tooling. And you need organizational changes, probably. So although I said it's another silo, typically you need some kind of a systems engineering role and maybe a kind of systems engineering department or so. You must be careful that you don't have the extreme, that it's really only a silo. Of course, they are strongly connected for all the other disciplines. But you have then a new organizational unit, and sometimes systems engineers think they are the chief engineers because they overlook the whole system and they decide about everything. So is it correct? Are they the chief engineers or on the same level? So, but in any case, it's a shift of responsibility, and that's also tough in organizations, of course, because people don't want to lose their responsibilities and their power. So it's a big transformation thing, but you can start small. So it's not this, oh, that's too big for us. We will never start with this. You can think big, but start in small steps.
Christian, do you have some experiences within your organization? So was systems engineering there from right off the beginning?
Well, per definition, as Timothy, you said, it's kind of always there, but not explicitly. What we have done in the meantime is actually we made some changes, like, for example, now having an explicit systems engineer on board that at least overlooks the motor as a system, which is not the whole system per se for our case, but at least there's someone who's now responsible for bringing the relevant people from the individual components together. And what we additionally have done, but that's rather something that implicitly happened through those pains that we went through, which I just presented, is that for us, oftentimes it is now easier to, at least through requirements, for example, have a point where we can identify that there are interfaces or interdependencies between the different components, and that makes it easier for us to then say, let's set up a meeting or whatever, or just go talk to each other between the different components or between the different departments. And that already helped quite a lot. So it's not necessarily a big organizational change that happened, but rather through the identification of, hey, we have a problem there, we need some tool, and requirements engineering in that case was the tool to explicitly, for example, allocate requirements to the responsible components for the realization. And that led us to already seeing, hey, we have 2 components assigned to 1 requirement. So that implies that those people should talk to each other. And that already kind of made a big difference for us, at least.
Yeah, thanks. When you already mentioned requirements engineering could be a tool, or the artifacts that come out of requirements engineering could be a tool. The topic of today's session is how requirements engineering could help to implement or introduce systems engineering, especially into organizations that are not that mature as of today. So what do you think? What could be a good starting point when looking to requirements engineering, especially I think on that doesn't matter if this is kind of involving stakeholders, documentation, validation. What do you think? What could be good starting points for organizations to do more kind of system thinking?
Yeah, what we, for example, introduced rather early after stumbling across those issues was to explicitly distinguish between system requirements, subsystem requirements, and component requirements. So through that simple differentiation of just asking the question, is this a system requirement? Is it a subsystem or component requirement? Already kind of implicitly led people to establish that thinking in their everyday work. So that made a huge difference for us, for example, because previously we only had, like, in German, Lastenheft, one huge document that kind of held all the requirements that people kind of had in mind, but we didn't necessarily distinguish whether it is a requirement that addresses the product as a whole, whether it is a simple software requirement, whether it is a mechanical requirement, a hardware requirement, or whatsoever. And just by making that differentiation in the documents and in the subject of the requirements already made a big difference.
Okay, means having this kind of, let's say, on the one hand side, abstraction levels, but on the other hand side, for sure, also levels where let's say, that how the system is built in general. That already helped people to be more, let's say, precise and also to solve these issues. As you mentioned, if you have, for instance, 1 requirement that's related to 2 components, just to identify these issues.
Yeah, exactly.
And do you think do you use models more often? Do you use more textual requirements, or just thinking loud? When thinking in systems engineering, at least in my small mind, I often think in kind of models in systems engineering. And for sure, this is not the whole truth, but is this helpful as a for an organization to do more modeling in requirements engineering, to be more, let's say, to come a step forward into systems engineering? Tim.
Yes, modeling. Modeling. Well, of course, I'm an advocate of modeling. I'm surprised that you think your third thinking is modeling when you hear systems engineering. Most people think, oh, tons of documentation. So
Yeah.
No modeling. That's nice, but after 20 years MBSE. Of course, I think it's important. Well, first, I think it's important to do this because, well, we create valuable information and we should store valuable information in models to make this accessible for machines and not store this in documents in Word. It's digital, but not accessible for machines. So we need machines. AI is the best example nowadays. That's to make it accessible. Of course, they can also read documents, but it's much better if you have models behind that. But also for the people, I think models are helpful. They can get lost in models and the details of activity modeling and all this stuff. But it makes this more abstract level of systems engineering. It's more abstract, no? And models make this more tangible than documents. You can touch it a bit, and if you have executor models on the systems engineering level, which is getting more and more, they are used more and more, then you really can touch that level. So I think that's a big advantage. And on the same time, the risk that people get lost in modeling.
Okay, great.
Yeah,
and I also think when, let's say, as Christian mentions, these different levels, maybe as mentioned, for sure, there's not only this model where you have all these details, but especially in models, you could add more abstraction, and that's, I mean, the people involved, for them, it's getting more and more clear. If you're talking about these different levels, what to focus on and to understand the whole system, or to also to understand components or functions in detail.
Yeah,
absolutely.
I love to say modeling is the art of being very concrete on an abstract level.
That's a very good way of saying it. And I can only highlight what you both said, because that is also applicable for us. We are currently mostly working with text-based requirements. So we are mostly working with requirements in prose, but we are more and more starting to not model yet, but we are at least creating diagrams. So it's something, I'd say. And especially paying into what I've previously said with the differentiation of the levels, what helped us a lot was to create very simple context diagrams, for example, to just get people aligned on what are we actually talking about right here, and to being able to, on a abstract level, very easily decide or define where are interfaces and where are interaction points between the different components and therefore the involved people. So that already helped us a lot in creating a very accessible and very easy first step for people to get a common understanding of what is it all about eventually. So just seeing, for example, that the context diagram on the system level is different than the one on the component level already kind of was a very enlightening moment for some of our colleagues.
Yeah, I could imagine. When looking to this, let's say, different kind of, let's call them kind of entry points that could be used from requirements engineering to be more major in systems engineering for the organization. You just mentioned context modeling. Is this something where you would say is this, let's say, a small step with creating kind of huge impact, or has created a huge impact?
Yeah, definitely. Absolutely. Because it made people more aware not only of the subject matter of the requirements, but also of, as the name already gives it away, of the context. What do we need to consider eventually? Like, for example, there's a technician in the field that has to mount the fan somewhere.
Sure.
Just simply seeing a stick figure in the diagram helped people to understand, that's something we also need to consider when coming up with the requirements and then eventually the design. And I think, as simple as it sounds, just having that stick figure there explicitly and looking at the diagram, even if it may look very, very simple, kind of is a very good reminder to actually explicitly make yourself think from that perspective.
Yeah, I think that's sometimes surprising. It's sometimes so easy, no?
Yeah.
Simple diagrams. For me as an external, I thought, that's so easy, but it triggers something, and well, there are clever people in the room, but it triggers them to get maybe the right mindset or the right perspective on the topic. Yeah.
Yeah, I think you're kind of, especially in development, you're oftentimes stuck in your thinking from development perspective and just getting dragged out of that perspective and being forced to take another perspective, may it be through context modeling, may it be through something else, already gives a lot of enlightening moments just to have that brief reminder that there are other things to consider than development or the client only.
Mm-hmm.
Like, as I've said in my 3 scenarios, manufacturing, for example.
Yeah. I had a discussion with a team, it was many years ago, hot discussions in the room with different disciplines and so, and they had diagrams on the wall, and they make it more and more abstract. In the end, there were only 3 boxes for the system. Oh, we have an input, we have processing, and we have an output. And yeah, that was the output. So, but somehow it helps. So no, it sounds like the people were completely stupid there, but no, it's helped. So
I think it helps.
Yeah.
I think that
and
level
this
of
picture was
abstraction,
the conclusion of this 2-hour discussion. So was okay, that's
I think the abstraction, for that matter, also helps people to not get lost too much in the detail.
Absolutely.
But to again get themselves on a higher level of abstraction and to see that we have the systems thinking again, to see the thing as a whole and not get lost in one minute detail.
The input thing, that's for the software people there was data input, but for the mechanical people there were also input from the outside. So
sure.
It was on the system level. Also.
Yeah.
Yeah, that's a very good point, actually.
Indeed. I think this is also important to understand that also, let's say, from the environment, what's not only zeros and ones in digits, that there is also something that's happening around, especially if you have a kind of fan or a robotic system, where you also need to measure the whatever the speed, the rotation, and all this different stuff that will give you some input parameters at the end. Coming back to one point that's rising in my head when looking to this kind of transformation process where we started in. This most often also has to do something with the culture in the organizations. So what do you think? What's needed at kind of culture in this kind of organizations, and who could drive this shift? So is this more from a kind of, let's say, smaller whatever pilot project, just motivating other people to see that something is working, or is this more coming from a kind of top-down idea? So do you have some experience for both, maybe pros and cons?
Well, I can start with this pilot project thing that you mentioned. That's, I think, for sure a good starting point, a pilot project, and then promote the success stories in the company of the pilot project. But at the same time, you need the executor support, of course, from the top. But if you start from the top, well, typically you get a lot of resistance. If you only start from the bottom, then you have this pilot project, and everyone is happy in this project, and then that is nothing more happens. So now you need both. But pilot projects are definitely very good. And then do internal marketing, no? So celebrate the success.
Yeah.
Well,
yeah, I'm totally with you on that, Tim. And I think what's also helping a lot, thinking about pilot projects or even doing like guerrilla SE, so to say, is that as soon as people start recognizing that the things that are done, like just talking to each other more frequently, or to like get a space where you synchronize regularly, already helps people to adapt that for themselves by just experiencing that something is that some project or some people are doing something different, and it seems to be working for them. So I think that kind of leading by example, so to say, also is a very, very powerful and very valuable measure with regard to that.
Yeah. I've just seen that there is a comment or a question coming in from LinkedIn. So I'll also motivate the others. If you have some questions or remarks, please just place them as a comment. So Adil is asking if requirements engineering is a gateway to systems engineering, then the real question might not be how we write requirements, but then how well requirements engineering enables system thinking, critical thinking, design thinking, just to kind of explore this tension of this, let's say, overall system. How do you see this? How do you see that requirements engineering could enable this kind of system thing? I think it can, but do you have some examples here?
Yeah, I think that kind of pays into the story that I've told previously with our first step in differentiating between the different system levels. I think that is, for example, please, Adil, correct me if you mean something else with that. But I guess that is, for example, one step that highly enables systems thinking or systems engineering for that matter. And I think there are a lot of potential touching points between RE and SE, and we should definitely regularly evaluate thinking about our RE methodology, whether it is enabling, as Adil already said, systems engineering principles, or whether we may have some structures, methods, or processes that maybe even hinder systems engineering or system thinking for that matter. Like, for example, too strict responsibilities, I could imagine, for component specifications or whatsoever, could lead to requirements engineering not necessarily enabling, but rather being a roadblocker for systems engineering principles.
Yeah. And I would also in the requirements engineering field involve the engineers from the different disciplines, not all of them, of course, but some of them. So take away their toys. So they focus on the solution stuff, take away their toys, and now they're in the requirements field. At the same time, you have to make this requirements engineering more sexy. Now, it's not about writing requirements and tell them the difference about shall, should, and blah, 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 and so forth. and the templates and so forth. It's important, but it's not sexy. You know?
Yeah.
And then it works. So I remember nice workshops with people, and there was a positive energy in the room, and they discussed on the system level their requirements, and they were mechanical and software engineers, but in that moment they were all systems engineers. So it can work. Yeah. And it works best in the requirements engineering field if you work with system architectures. Then all the engineers see their components there, and then the software, mechanical, and other people are back in their domain, in their discipline.
Yeah. I think on this higher level, it's more easy to abstract also, and as you mentioned, I think what's super important in these areas is to have a kind of, let's say, broader view on what are the capabilities on the one hand side from the system. What is required from the, let's say, in this kind of end product by the system? Doesn't matter if this is kind of mechanics or if this is software, so they need to go hand in hand. And maybe here, just a question. I mean, you both know this digital design, the idea from Bitkom, also thinking a bit more from, let's say, business perspective, technical capabilities, thinking about, let's say, the digital product, but also the more kind of analog and mechanical things. Is this kind of thinking already helpful in this area to think more into systems?
I'd say so, because it definitely encourages to integrate the disciplines more with each other and to not have too strict distinguishing between the different disciplines. Like, for example, first you do requirements, then blah, 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 the typical waterfall thinking.
Yeah.
And I think to just see that more holistically and in a more integrated or more iterative even manner already, and that kind of again pays into Adil's question, I guess, enables systems engineering more than if you don't have such an integrated approach.
Yeah, digital design, digital is the material you work with. So it's similar in systems engineering. No? It's the systems components you work with. It's not software, it's not mechanical, it's a more abstract thing.
Yeah.
And that's what I meant before. So engineers don't like wordsmithing and writing stuff, and so at most, I guess. So it's unsexy. But if you have do this as a material and they really can work with it, modeling can help, of course, with that. I not mentioned this before, but it's quite nice. But other things, then it's a really good entry point for systems engineering if it's not already there.
Yeah, I think models for sure could help to structure and to communicate thoughts and be, let's say, precise or abstract on what level you are. And on the other hand side, I think mindset doesn't matter if you call this digital design or system thinking, or let's say being more open-minded, just let's say going away from the silos to make people more thinking in a holistic way, and just being more open also to the other disciplines. Then I think this is a good starting point.
I think the most important thing that people should start to recognize or include into their perspective is that eventually it is about the product as a whole and not about a single component. And I think that's what digital design also kind of enforces, or at least facilitates to some extent.
Yeah. When looking to the pain points that you have experienced during the last decade or decades, so what do you think, in which areas, or what is, let's say, what's best suited for typical pain points you have seen as a door opener for more systems thinking in this area? I mean, you already had some in your introduction, Christian.
Yep. I think I would again highlight what I've already repeated kind of once or twice, is the explicit naming of the subject or the system level of the requirements. I think that is the entry point with the least threshold, the most accessible for people, and also the easiest to kind of convey to people not necessarily being involved into systems or requirements engineering too much, but it's rather easy to show and to tell people how those different system levels work and what the intent and what the problem you want to solve with that is. And I think the variety of potential problems that you can solve by just introducing that differentiation is quite vast. So that, from my personal point of view, is what probably is, for me personally, the best and easiest starting point that I'd also recommend to the audience.
Yeah, look for, first identify your pain points. No? So where's actually the pain point? So you see there's something is going wrong, but what's the pain point? No? And then see, okay, is this something that I can solve? If you have your 1, 2, 3, 4, 5 pain points, then look for the low-hanging fruits. But, well, we said requirements engineering is a good entry point, but at the same time, I heard this several times, I'm not sure if I'm convinced, but people said, if you would like to introduce systems engineering, don't start with requirements engineering, because that's a tough nut to crack. They are really hard to change. You cannot change requirements engineering in an organization. That's start somewhere else. That's much easier. No? Because often the answer is, oh, we already have this tool, this requirements management tool, that is fixed, we cannot change it. So,
story of my life.
Yeah, sometimes it's probably true. You see, okay, it's too tough to change something there. Let's start there.
Okay. That's
the same...
interesting. Yeah. I mean, what is interesting, if you, I mean, not you, but if people are arguing from a tool perspective, because for me, a tool in the requirements engineering is a kind of vehicle to support your work, but you need to have your methods, your skill set, and all your, let's say, your thinking in abstraction levels and all this stuff you need to have at hand. And then this could be supported by tools. But I'm completely with you. I mean, when looking to organizations, people are used to their tools. They do their work with these tools, and they fight for these topics as well.
Right. Mm-hmm.
Just seeing another comment is coming in from Adil. Organization structure requirements engineering predominantly through hierarchical and composition allocation. In your view, this structure generally supports system thinking, or does this risk in fragmenting kind of system cognition?
I'd say it depends on how it is eventually executed. So it can help by just giving the overall structure and the awareness that there is a system level. But if eventually all the engineers and people involved in development are only looking at the requirements in their specific silo, in their specific component, it can also, as you've already mentioned, risk that people are again losing oversight over the system as a whole and start to dive into their specific component again. So it's a clear it depends for me.
Typical answer. Yeah. But this is a nice question, which reminds me what we discussed before, and don't forget the organization structure. It's often systems engineering is a little bit, if it's not already there, it's against the organization structure. So there's a lot of resistance that comes from that field.
True. Tim, you already mentioned that you have heard from the one or the other that maybe requirements engineering is not the best way to start when introducing systems engineering. What's absolutely fine. But the question is, when looking to, let's say, a common mistake when introducing systems engineering to organizations, what is the, let's say, most or biggest mistake people or organizations could do? Do you have some ideas?
Well, it's the typical mistake also in other disciplines, start with the solution and not knowing the exact problem. So in systems engineering, well, I'm a SysML guy. The people buy a SysML tool, they buy trainings, they do SysML, they start modeling. And after weeks or months, they realize, when do I know when I'm finished with my model? So when I'm done and so forth.
Yeah.
Then they realize, oh, we actually don't know the problem for our models. So, and then when we ask, what's your problem? They don't really know it. So it sounds easy, this question, but it isn't easy. So first, exactly know your problems, and then go to the solution. So, and that's a typical pitfall, not start with the problem. Start with the great technologies you hear from the market, from the tool vendors, from the consultants. Do this, do that, then you are a superstar.
Yeah.
I think that's the biggest mistake.
Okay.
What I would add to that as a further pitfall, at least from my perspective, would be to, as also you've already mentioned, Tim, is to treat systems engineering as something that is completely newly introduced to a company as if it was not already there. And I think just, again, creating the awareness and recognizing that we are already to some extent or in some interpretation doing systems engineering. And by figuring out what our problem is, we can explicitly look at those pain points or those problems and see how we can further develop or how we have to change our already existing way of working for the problems to eventually go away by a solution. And that solution may be through systems engineering practices. But I think that through treating systems engineering as something that is external and is now brought to the organization, will most likely, in most cases, lead to more resistance than as if making people aware that they are already doing systems engineering.
Maybe there's coming in one more thing from LinkedIn. Looking to the time, I think we have time to just have a look on this comment. Yeah, I think we slightly have discussed on this part, especially how to break down the silos.
I think what also helps there, which we haven't discussed yet, is to understand what my explicit subsystem function, for that matter, to stay in the wording of the comment, is contributing to in the overall system. So I think through, for example, traceability and making people aware of what they are contributing to in the whole, kind of can help to break down the silos, because you're not only thinking about your specific function and having the understanding that it may be a customer function or whatsoever, but to then again see what are we contributing to in the overall picture. And that makes people, I think, again, more aware of what they are actually working on and what other components or what other subsystems or whatsoever are necessary or also contributing to that specific function in the system as a whole. So I think that can be a tool to make people, to break up those silos and to make people aware again of what the overall system means again.
Yeah, if you trace it, as you said, to the requirements and you realize, oh, I do not fully satisfy this requirement, only a part of it, it emphasizes that you are only a part of the system.
That's true.
Systems traceability may not be the most fun part of requirements in systems engineering, but it's definitely worthwhile.
No, I think in general, traceability is not a fun part at all, but for sure you need also in traceability, you need to understand and you need to ask yourself, what's the point you want to solve? And just to maintain these traces and links between requirements or other artifacts that are necessary that could help you. But if this is maintained in a good way, small enough, but in a good way, then I think this could help in answering many points.
You get it for free in modeling. No? So if you build up your model, then traceability is in there. So it's not an add-on task. So, oh, now we have to add the traceability. No, it's there because in the model you build your system and everything is connected in the system somehow, and that's part of the model. It's already in there.
Yeah.
Do not say it's easy, but it's not an extra add-on task. So you are then not that guy who has these Excel tables with managing the traceability.
That's true. But I mean, what's even harder is when you have both models and textual documents or textual requirements, and then having, let's say, the interconnection between certain functions, data elements, and so on. And this makes things it's solvable, but it's not an easy task.
Yeah, in the perfect world, the documents are only generated from the models, but we are not in the perfect world.
Yeah. Good. Unfortunately, we are coming to an end already. So maybe one last question to you. What would be your advice to the participants to introduce systems engineering? What would be a first step from your perspective, Tim?
Yeah, so first, do it. Do systems engineering, of course. And do systems thinking. Don't do this in thinking in causal change. Consider the whole life cycle, think in networks, and consider the context and so forth. And it's not only about engineering, so it's not only at your job, it's everywhere. So it's really important to think in systems. And in the US or in other countries, they train this in school, in the kindergarten. It's really important to do this. So go in that direction, and then, start small. Look for the low-hanging fruits, celebrate successes, and then learning is fun and helps you get ahead.
Great, thank you, Christian.
I would take up one of Tim's statements from previously. Start with the problem and not with the solution.
True. Yeah, yeah. But this is true in most of the things we are doing. Thank you, Tim. Thank you, Christian. This was a great discussion. Time was running away. I hope everyone in the world who joined this session enjoyed it. And as mentioned, also, if you have some additional questions after the session, please use the chat or contact us. I will distribute the questions to Tim and Christian if something is coming in. If you like this session, share this recording within your network after the session. And maybe my final statement is, I think when starting with systems engineering, start small, think big, like in many things that we are doing. And I think requirements engineering could be a good starting point. At least you are a bit structured. You have some analysis thinking. You could do some kind of small systems thinking. But I think the most important thing is do not think in silos. Get rid of the silos and be more comprehensive and more holistic in your thinking. Thanks a lot for joining, and hope to see you in one of our next roundtables next month.
Thanks, everyone. Have a good
Thank
one.
you. Bye-bye.